So we've worked with some previous lessons on solving radical equations. We're going to do some more practice today. So we've got first one, the radical of x equals 5, or it's also known as the square root of x equals 5. We need to undo that to solve for x. And remember, with your radical equations, you always want to verify that the value that you're getting for your variable x, when you substitute it back into the original equation, it makes a true statement. If not, we would have to say it's an extraneous solution. So we have the square root of x equals 5. To undo the square root, we know we have to square it, so we'll square each side, which means that x is equal to 25. Now we have to check and make sure that's a valid result. So if we substitute back into our equation, the square root of 25 we know is 5. Therefore, we've got the correct value for x to make that equation true. Now we've got 3 times the radical of x equals 12, or 3 times the square root of x equals 12. We want to undo this equation to solve for x. Well, to undo multiplication, we have to do division, so we'll divide each side by 3, which gives us the square root of x equals 4. To undo the radical, we have to square each side, so x equals 16. Now I want to take that and put it back into the original equation and make sure that it's a true statement. So we've got 3 times the square root of 16 equals 12. Well, we know 16 is a perfect square, so that's a value of 4. 3 times 4 is 12. We've got the correct value for x to make that equation true. X is equal to 16. Again, we want to solve for x. So to undo this equation, we could square each side. So x equals 49. Now again, we're going to substitute it back into the original equation to make sure that it's a valid result. We know the square root of 49, 49 being a perfect square, is 7. 7 does not equal negative 7, so we'd have to say this is an extraneous solution, or it's often we could also refer to it as no solution for the equation. So again, because our value for x when we substitute back into the original equation gives us an invalid statement, cannot use it, it's extraneous. So let's solve this equation. The square root of 2x equals 10. To undo this, we would have to square each side of the equation. So 2x equals 100. Then we would have to divide by 2, so x equals 50. Now we have to check to see that this is a valid answer. So going back to the original equation, we know 2 times 50 is 100, and the square root of 100 is equal to 10. So x is equal to 50. Again, here's another equation for us to solve. We've got the opposite of the square root of x equals negative 3. So the opposite, that's acting like a negative 1 being multiplied. So to undo that, we would divide by a negative 1. So we've got the square root of x equals 3. And we know to undo the radical, we have to square each side of the equation. So x equals 9. We're going to substitute it back into the original and make sure it's a valid result. So we've got the opposite of the square root of 9 equals negative 3. 9 is a perfect square, and we know it has a value of 3, and the opposite of 3 is negative 3. So we've got the right value of x to make that equation true. Here we've got the radical of x equals negative 3. So to undo this equation, we would square each side. So x equals 9. Now if we substitute that back, the square root of 9, we know 9 is a perfect square, which should be 3. 3 is not equal to negative 3. Therefore, we have another extraneous solution. Let's solve this equation. 3 times the radical of x minus 6 equals 0. So we want to get the radical alone. The first step would be adding 6 to each side of the equation to undo the subtraction. Then, to undo the multiplication, we would divide by 3. To undo the square root, we would square each side of the equation. So we have 4 being the value for x. We want to make sure that it's a true statement, so we're going to substitute back into the original equation. Well, the square root of 4, that's 2. 3 times 2, that's 6. 6 minus 6 is 0. So x is equal to 4. Let's solve this equation. We've got the radical of the quantity x plus 4 is equal to 5, or the square root of the quantity x plus 4 is equal to 5. To undo this, the radical is alone, so to undo that radical, we have to square each side of the equation. To undo the addition, we would subtract. It looks like x is 21. Again, we're going to substitute it back into the original equation and make sure it's valid. Again, simplify what's underneath the radical. 21 plus 4, that's 25. And we want to take the square root of 25. That's a perfect square, which is 5. It's true, so x has to be equal to 21. Here's another equation. 4 times the radical of the quantity x minus 7 plus 12 is equal to 28. Again, when we're solving these equations, the goal is to get the radical alone. So we're going to undo our order of operations. The first part to undo is the addition, so we're going to subtract 12 from each side. Then we're going to undo the multiplication by dividing by 4 on each side. And we have to undo the radical. So we know to undo the radical, we're going to square each side. And then to get x alone, to undo the subtraction, we're going to add. The question is 23 valid for the equation? Well, let's find out. We're going to substitute it back into the original and make sure it's true. So order of operations, simplify what's underneath the radical first. So take the difference. Can you simplify the radical more? Yes, 16 is a perfect square, which is 4. 4 times 4 is 16. 16 and 12, that's 28. That's a valid result, so x is equal to 23. So here we want to solve this equation. Again, the goal is to get the radical alone. So the first step would be to undo the addition. The next step to undo would be the multiplication. Now we have to undo the radical. So we know we've got to square each side of the equation. And then we have one addition to undo. So x equals 30. Again, we have to see if 30 is valid for the equation, so we're going to substitute it back in and see what results. Order of operations, say we have to simplify underneath the radical first, so this would be the square root of 36. 36 is a perfect square, and so we know the square root of 36 has a value of 6. 2 times 6 would be 12. 12 and 9 give us a total of 21. So that's a valid result. X has to be 30. So again, we want to solve our equation. The goal has been to get the radicals alone. And if you notice, we have a radical on the left. We also have a radical on the right. And for all intents and purposes, they are alone. So we know to undo a radical, that means we have to square it. So we're going to square each side of the equation. So these will undo each other because they're inverse operations that we've talked about before. And so now we have the equation 3x minus 17 is equal to x plus 21. We're going to undo this linear equation like we've done for all the other ones. So we've got some like terms to combine. So we could subtract x from each side. Then I could add 17 to each side. And last but not least, to undo the multiplication, we could divide by 2 on each side of the equation. So it looks like x is 19. The only way to be sure, though, is to substitute it back into the original equation and make sure that it's valid. So let's see. We're going to have to multiply 3 by 19 and subtract 17 to see what we're working with. On this side, we're just going to take 19 and add it to 21. We've got the square root of 40 equals the square root of 40. That's a true statement, so x has to be equal to 19. All right, one more equation. We've got the radical of the quantity 4x minus 12 equal to the radical of the quantity x plus 3. Again, the goal is to solve the radical equations by getting the radicals by themselves. And here again, we've got one radical on the left, one on the right. Nothing is being added or subtracted on the exterior of the radicals or multiplied, so they are alone. To undo a radical or a square root like this, we would square each side of the equation and then undo it according to your order of operations. We've got a linear equation here, so we could subtract x from each side of the equation to combine those like terms. And then we could add 12 to each side of the equation to undo that subtraction. And then last but not least, to undo the multiplication, we could divide by 3. So it looks like x is equal to 5. Again, we have to check to make sure it's valid, so substitute it back into the original equation, and let's see what happens. On the right-hand side, we have 5 plus 3, that would be a total of 8. The left side, 4 times 5, that's 20. 20 minus 12, that also is 8. You've got the radical of 8 equaling radical of 8. It checks out. X has to be equal to 5.